Right now, at this exact moment, a spacecraft older than most of your parents is doing something that should be scientifically impossible. It is sitting more than 15 billion miles from where you're standing, in a place so cold, so dark, and so far beyond anything humans have ever touched, that the engineers who built it never imagined it would still be alive today. But before we go any further, please take a moment to subscribe to this channel and help us reach 1,000 subscribers. Your support allows us to keep bringing you incredible stories like this. Now, let's continue. And yet, in the last few weeks, NASA quietly confirmed something that sounds like it belongs in a science fiction movie. Except every single word of it is real, verified, and happening right now. This is the story of Voyager 1 and what it just encountered out there in deep space. It's been called one of the most impossible milestones in the history of human exploration. Let's start with the number that NASA itself has confirmed. On November 18, 2026, Voyager 1 will officially become the first human-made object in history to cross one full light day of distance from Earth. That is approximately 16 billion miles, or nearly 26 billion kilometers. To understand how insane that number actually is, think about it this way. Light is the fastest thing in the entire universe. Nothing travels faster. Not radio waves, not gravity, nothing. Imagine standing on Earth and trying to hold a conversation with someone so unimaginably far away that even light, the fastest thing in the universe, needs an entire day just to carry a single message. That is exactly the reality of Voyager 1 today. Traveling at 186,000 miles every second, light still takes a full 24 hours to bridge the enormous distance between Earth and the spacecraft. For the engineers at NASA's Jet Propulsion Laboratory, this isn't just a fascinating fact. It's part of their everyday routine. Suzanne Dodd, the Voyager project manager, often explains what that distance really means. If she sends Voyager a simple greeting, "Good morning, Voyager," the message begins a journey that lasts an entire day before it finally reaches the spacecraft. Even if Voyager could answer immediately, that reply would spend another full day crossing the same unimaginable distance back to Earth. A single exchange, just one message and one response, now stretches across 48 hours. Take a moment to picture that. The machine on the other end of that conversation wasn't built with modern computers or cutting-edge technology. It was designed in the 1970s, long before the internet, smartphones, or most of the technology people take for granted today. Yet somehow, nearly half a century later, it continues to operate in a place so distant that even light no longer feels instant. Voyager 1 has already rewritten history once before. In August 2012, it became the first spacecraft ever to leave the Sun's protective bubble, known as the heliosphere, and enter true interstellar space, the vast region that exists between the stars. That achievement alone secured its place in history. But the milestone it is approaching today is different. This isn't about crossing into a new region of space or discovering a new law of physics. It's about distance itself. It is about becoming the farthest-reaching object humanity has ever created. What makes that achievement even more extraordinary is that, only a few years ago, Voyager 1 came frighteningly close to never reaching this moment at all. The story takes us back to November 14th, 2023. Without warning, something went terribly wrong. Instead of sending the clear scientific information engineers expected, Voyager 1 began transmitting a strange, repeating pattern of meaningless data. Across more than 15 billion miles of space, the spacecraft's voice had suddenly turned into cosmic gibberish. For 5 long months, no one at NASA knew why. Unlike problems on Earth, this wasn't something a repair crew could fix. No astronaut could be sent to replace a broken component. Every command sent toward Voyager needed roughly 22.5 hours just to arrive, and every reply required another 22.5 hours to return. Every attempt to diagnose the failure demanded nearly 2 full days of waiting, with no guarantee that the next command would solve anything. Month after month, engineers carefully examined every clue they could find. Finally, in March 2024, they uncovered the source of the mystery. Hidden deep inside one of Voyager's 3 onboard computers was a tiny corrupted memory chip. After 46 years of non-stop operation, the chip had likely worn out, or perhaps it had been damaged by a stray cosmic ray somewhere in the endless darkness of interstellar space. The damaged chip contained part of the spacecraft's own operating code. Replacing it was impossible. Repairing it was impossible. Even bypassing it using ordinary methods wasn't an option. Most missions would have ended there. But the engineers at NASA's Jet Propulsion Laboratory refused to let Voyager's story end that way. Instead of giving up, they chose a solution that sounded almost impossible. They rewrote the damaged software completely from scratch. Once the new code was finished, they divided it into smaller sections and carefully moved each piece into different working areas of Voyager's ancient memory, avoiding the damaged chip altogether. In effect, they performed brain surgery on a spacecraft nearly half a century old from more than 15 billion miles away, relying on software and documentation created by engineers who had built the spacecraft decades earlier. When everything was finally ready, the team reached the moment they had been working toward for months. On April 18, 2024, they transmitted the command across the darkness of interstellar space. Then there was nothing left to do but wait. Nearly a full day after the command left Earth, it finally reached Voyager 1, drifting silently through the darkness of interstellar space. There was nothing the engineers could do now except wait once again. Every eye inside NASA's Jet Propulsion Laboratory remained fixed on the monitors, knowing that the next signal would determine whether months of painstaking work had succeeded or failed. Then, on April 20th, 2024, the answer finally arrived. Readable data began flowing back to Earth. Voyager 1 was speaking clearly again. For Linda Spilker, Voyager's project scientist at JPL, the moment could be summed up in just a few words. She simply called it a great day for the mission. But for the people who had lived through those long months of uncertainty, the reality felt far more emotional than those words could ever capture. Inside the control room, silence had taken over. Engineers sat motionless, watching their screens, waiting to learn whether computer code that had been rewritten entirely by hand and transmitted across billions of miles at the speed of light could actually revive a spacecraft built before many of them were even born. Against all odds, it had worked. That incredible recovery brings us to today. Less than 3 years after NASA nearly lost Voyager 1 forever, the very same spacecraft is preparing to cross another historic milestone. The machine that engineers once feared might never communicate again is now on the verge of becoming the farthest-reaching object humanity has ever created. Even more remarkable is what Voyager has been doing while simply staying alive. As it continued its lonely journey across billions of miles of empty space, it quietly kept sending home discoveries that are forcing scientists to rethink what they believed they knew about the region beyond our solar system. To understand those discoveries, however, the story has to travel back even further, to the moment Voyager 1 first crossed into interstellar space. That was the moment when reality stopped matching the predictions. In August 2012, Voyager 1 crossed the heliopause, the invisible boundary marking the outer edge of the Sun's influence. This boundary forms the edge of the heliosphere, a vast protective bubble created by the continuous outward flow of the solar wind. Scientists believed they knew exactly what would happen once the spacecraft crossed that line. They expected silence. Beyond the heliosphere, Voyager was supposed to enter a calm, mostly empty region between the stars, completely separated from anything happening back near the Sun. But the universe had other plans. Instead of finding quiet emptiness, Voyager 1 stumbled upon something no one had anticipated. The surprise revealed itself in 2013, when scientists carefully examined data collected by the spacecraft's plasma wave instrument. Hidden inside the measurements was a faint but continuous vibration in the surrounding plasma, almost like a soft, steady hum echoing through interstellar space. At first, the discovery puzzled researchers. After all, instruments designed in the 1970s were never expected to detect such delicate signals with remarkable precision. Some wondered whether the strange pattern was simply background noise. Others questioned whether the instrument itself had malfunctioned. But as the data continued to be analyzed, one extraordinary truth became clear. The signal was real. Voyager wasn't hearing a faulty instrument. It was detecting the natural oscillations of interstellar gas itself. Those tiny vibrations carried an enormous scientific reward. For the first time in history, scientists could directly calculate the actual density of the material filling the vast space between the stars. For decades, that measurement had existed only in theory. No telescope could confirm it. No simulation could prove it. Only a human-made spacecraft traveling into interstellar space and quietly listening could finally provide the answer. Yet Voyager's greatest surprise was still waiting. Researchers had always assumed that once the spacecraft entered true interstellar space, the Sun's influence would effectively come to an end. After all, that's what crossing a boundary is supposed to mean. Once you're beyond it, you're beyond it. But once again, Voyager refused to follow the script scientists had written for it. Crossing the heliopause was supposed to mean leaving the Sun behind forever. That was the expectation. Once Voyager 1 had passed the boundary, scientists believed the Sun's influence would finally come to an end. After all, that's what a boundary is supposed to represent. Once you're beyond it, you're beyond it. But Voyager 1 had a different story to tell. As scientists continued studying the data arriving from deep interstellar space, they realized something astonishing. Even billions of miles beyond the heliopause, the spacecraft was still detecting occasional bursts and ripples traveling through the surrounding plasma. After careful investigation, researchers traced those disturbances back to our own Sun. Powerful solar eruptions and shock waves were somehow continuing their journey far beyond the heliosphere, rippling through the interstellar medium in regions that scientists had believed were completely outside the reach of our solar system. It was a discovery that forced researchers to rethink one of their most basic assumptions. The Sun's influence did not end as abruptly as anyone had imagined. Its fingerprints stretched much farther into interstellar space than calculations had ever predicted, making the boundary between our solar system and the galaxy beyond far less defined than textbooks had long suggested. The remarkable part was that none of this knowledge would have existed without Voyager 1. Here was a spacecraft designed in the 1970s, operating with less computing power than a basic calculator, somehow continuing to transmit reliable scientific information across billions of miles. Even today, many engineers find it difficult to believe that technology of that age is still functioning at all. And yet, Voyager's discoveries were only beginning. As the years passed and the spacecraft ventured deeper into interstellar space, scientists returned to years of accumulated plasma wave observations. Looking back through the enormous collection of data, they noticed something that had escaped everyone's attention in real time. The plasma surrounding Voyager wasn't remaining constant. Instead, the farther the spacecraft traveled, the denser that interstellar plasma gradually became. That seemingly small detail turned out to be enormously important. It revealed that the region beyond the heliopause was not a simple, uniform emptiness, stretching endlessly in every direction. Instead, it possessed structure. It contained gradients and regions where the density changed from place to place, shaped by physical processes that scientists still do not completely understand today. Once again, Voyager 1 was doing more than confirming long-standing theories. It was proving that humanity's map of interstellar space was incomplete, revealing details that no scientist could have verified until an actual spacecraft traveled there and measured them directly. While Voyager continued rewriting science far beyond the solar system, a completely different battle was unfolding back on Earth. The challenge was no longer making discoveries. The challenge was keeping the spacecraft alive. Year after year, Voyager 1's plutonium power source slowly lost a little more of its energy. With every decline in available power, engineers faced another painful decision. One by one, scientific instruments had to be permanently switched off so that enough electricity remained to power the spacecraft's heaters and, most importantly, its transmitter, the only link still connecting Voyager with Earth. Those choices were irreversible. Once an instrument was shut down, it would never operate again. There were no second chances. For decades, the engineering team has carefully planned every decision, constantly weighing which systems are absolutely essential and which ones must be sacrificed. Their goal has always been the same: stretch a spacecraft originally designed for a 4-year mission into one capable of exploring the universe for nearly half a century. That is what makes the upcoming Light Day milestone so extraordinary. Only a short time ago, in 2023, Voyager 1 came dangerously close to permanent silence. Today, that same spacecraft, rescued through remotely rewritten computer code, operating on steadily fading power, and sustained by the careful planning of a small group of dedicated engineers, is preparing to become the farthest-reaching object humanity has ever created. Even more astonishing, it continues to send back real, verifiable, groundbreaking scientific discoveries from a place no human has ever physically explored. When you stop and think about it, the odds are almost impossible to comprehend. This is a machine that nearly disappeared forever in 2023. A machine built with technology from an era before most of us were even born. And yet, against every expectation, it continues to rewrite humanity's understanding of the universe while traveling farther than anything we have ever created. By now, Voyager 1 had already accomplished something few machines in history could ever claim. It had transformed humanity's understanding of interstellar plasma, revealed that the sun's influence extends much farther into space than scientists had once believed, and exposed the hidden structure of the vast region beyond our solar system. Yet, instead of fading quietly into history, the spacecraft was preparing for another historic achievement. It was about to set the greatest distance record ever reached by any human-made object. That naturally leads to an even bigger question. What happens after Voyager 1 crosses that incredible milestone? Does its extraordinary journey of survival and discovery continue? Or are we witnessing the opening pages of the spacecraft's final chapter? The answer is more emotional than most people expect. When people hear that Voyager 1 is about to reach one full light day from Earth, many imagine it as the finish line of an extraordinary mission. They picture the story ending there, as though the spacecraft has finally reached its destination. But Voyager has no destination. Crossing one light day is not the end of its journey. It is simply another milestone on a path that stretches endlessly into the darkness of interstellar space, a road with no final stop waiting ahead. Understanding what comes next makes Voyager's story even more remarkable. At this very moment, the spacecraft is racing away from the Sun at roughly 38,000 miles per hour. That speed is so extraordinary that it could cross the entire continental United States in less than 5 minutes. More astonishing still, Voyager 1 has maintained that incredible pace continuously for nearly 50 years. As long as its transmitter continues working, it will keep moving farther away than any other object humanity has ever launched. But behind that remarkable achievement lies a bittersweet reality. NASA's internal projections indicate that sometime during the early 2030s, Voyager's slowly fading power supply will likely force engineers to switch off the last remaining scientific instrument. When that moment arrives, the spacecraft's transmitter, the single thread that has connected Earth and Voyager for nearly half a century, may itself have only a few more years before it falls silent forever. That realization changes the way this mission feels. The era we are living through today, when Voyager 1 is still sending usable scientific information back from a distance of one full light day, represents one of the final active chapters of one of humanity's greatest explorations. Every command transmitted toward the spacecraft, every faint signal collected by NASA's Deep Space Network antennas scattered around the world. Every successful exchange is happening on borrowed time. Only a few years ago, during the crisis of 2023, many engineers weren't even certain Voyager 1 would survive. Now, against all expectations, it is preparing to break another historic record. That is exactly why scientists and engineers at NASA's Jet Propulsion Laboratory often describe this moment as bittersweet, rather than simply joyful. Suzanne Dodd has spoken openly about how the team's mindset has changed. They no longer assume Voyager will always answer. Instead, every successful transmission has become something to appreciate, something to be thankful for. Each packet of data that safely arrives back on Earth feels almost like a small miracle, because everyone involved understands that another unexpected failure, like the one that nearly ended the mission in 2023, could happen at any moment. And next time, there may not be a solution waiting to be discovered. Yet even that will not truly be the end of Voyager 1. One day, its transmitter will finally fall silent. Humanity will no longer be able to hear its voice. No more commands will ever reach it. No more scientific discoveries will ever return. But Voyager itself will continue its journey, because the laws of physics do not care whether anyone is still listening. The spacecraft will simply keep moving. Even after the day finally comes when Voyager 1 can no longer answer Earth, its journey will not end. The spacecraft will simply keep moving. The universe does not pause because humanity has stopped listening. The laws of physics will continue carrying Voyager one farther into the darkness of interstellar space, just as they have for nearly half a century. For millions of years, it will drift silently through the emptiness between the stars, carrying one of humanity's most remarkable creations, the Golden Record.